This is a screencast on parallel circuits. In the circuit shown, two light bulbs, 10 ohms and 5 ohms, are connected in parallel across a 9-volt battery. Find the equivalent resistance. Find the total current. Find the current through the 10 ohm resistor. Find the current through the 5 ohm resistor. Since the resistors are connected in parallel, we use the formula 1 over R sub P, which is the equivalent resistance for resistors in parallel, equals 1 over R sub 1 plus 1 over R sub 2. So 1 over R sub P equals 1 over 10 ohms plus 1 over 5 ohms. If you use your calculator to find 1 over 10 and get 0.1 and 1 over 5 to get 0.2 and then add those together, you get 0.3. And we notice that the ohms are in the denominator, so the units here are 1 over ohms. But that's not the answer we're looking for. That's the reciprocal of the answer we're looking for. 1 over R sub P is 0.31 over ohms. So to find R sub P, we have to take the reciprocal of our answer. So we divide 1 by 0.3 and get 3.33. And the units are 1 over ohms, which is ohms. So there's our first answer. Now we want the total current. We want to use Ohm's law. Ohm's law says that the current is the EMF, electromotive force in the circuit, E, the voltage in the circuit, divided by the resistance. So if you want the total current, we have to use a total resistance or equivalent resistance. The electromotive force in the circuit is 9 volts. And the equivalent resistance in the whole circuit is 3.33 ohms. And if we round off our answer, we get 2.7 amps. Now we want the current through the other individual resistors. We notice in this parallel circuit that the 9 volts is the voltage across R1, and the 9 volts is also the voltage across R2, because there's a separate path you can go through, going through R1 only to get back to the battery. There's also a path you can use to going through only R2 to get back to the battery. So the current through the 10 ohm resistor, again, uses the formula E over R, but we have to know which R to use. The E for the 10 ohm resistor is again the 9 volts of the battery. And here we're talking about only the 10 ohm resistor, so we use 10 ohms for the resistance. When you divide that, you get 0.9 amps. If you're looking at the 5 ohm resistor, again, we'd use Ohm's law. Again, it's the 9 volts that is across the 5 ohm resistor. Now we're talking about only the 5 ohm resistor, so the 5 ohms goes in the denominator. When you divide that, you get 1.8 amps. This total current is the current in the supply wires, and that's got to be equal to the total current going through the two resistors. So if you add the 0.9 amps and the 1.8 amps together, you get the total current 2.7 amps.